Hi there. Welcome to a new episode of Julia Unboxing. In this episode, we will explore together some COVID data. I mean, it's a hot topic right now with all the second wave questions. So it was an opportunity for me to test some Julia packages to do some data exploration. So Pluto, which is a notebook, a reactive notebook that is very interesting, very young, but very interesting. Data frames, how to manage tabular data as you would do in most data-driven projects, and plots, because it's the first step in exploratory data analysis. We do a lot of plots. So how does it look like in Julia? So let's dive in. Here we have, actually it's a website where you launch your Pluto notebook, as you would do with the Jupyter notebook, if you know this, where actually you have cells and code, and we will see that just in a moment. But the very interesting part about Pluto, what sets it apart compared to Jupyter Notebook, for example, it's reactive nature. So actually here you see, this is, I mean, the gist of what we are interested in. We have some data, we have plots of confirmed cases for a number of countries, and the x-axis here is dates. So what does it mean to be reactive? It means that if I change the inputs, the outputs, all the related data changes instantaneously. So I don't have this mismatch between data definition and data usage. The tool tracks all the dependencies and do the updating for you. So this is very interesting for having. So I will just zoom back a little bit so that we see the menu. Here we have many countries, and then if I, for example, I will scroll down to France, where actually I live, and select France here. So control to add France. I add France to the list. Automatically it's added to the plot. We don't see it because this is the beginning of the coronavirus story. We're in February. And to roll the date, actually this slider controls the end date that I'm plotting. So as I move, I see how things evolved. So we see here Italy, then actually I think it's US and France, and then we will see that the US story got really big. I mean, this is no news, but and then we see that, for example, Brazil and India are actually increasing sharply. So with a tool like that, we can have this interactive aspect. I choose a country, any country, and I can see I can select many with the control and click, and then I can have this plot. So the idea is really, it's very simple data, but let's see how we've done that using the packages for data frames and plots. So now we dive into the code. And one cool thing about Pluto notebooks is that they allow you to order your cells in any order you want. So this is very interesting. Here I put the output of the notebook at the beginning, because that's what's interesting for a user. In other notebooks, actually, you are forced to have like a sequence of cells, and then once you need to execute them in the order to get the output. Here, because the tool manages the order and the links, it's transparent. So here, let's dive in. So data processing. So this is a part where actually, if you've never seen Julia, the using keyword is the one used to load packages. So here what we're doing is we're loading the package manager, activating the environment. Maybe I will explain that in a dedicated episode. But what's important here is that we're loading a number of packages: CSV, to read CSV files, so comma separated values. This is your typical text file and very used for data. Data frames, which is the tabular format that we will be using, and dates, because we have dates, and this is one of the tricky parts in many data science stacks, where dates can be tricky. And nice thing in Julia, it's included in the base Julia language. And then plots, and plot UI is actually just a goodie where we have these sliders without writing HTML. So, okay, so any topic around data is depends on the quality of the data. Here we have the source here, so it's URL where you get the CSV. This is actually I got this this link following a course by on the epidemic modeling by David Sanders, which is excellent. And actually they just started a new session of this course yesterday, and there are some hot news for this. I will keep that for the end. Okay. We have the URL, then we need to get the data. So we have the function download, we give it the URL and the name we want to give to this file. Once we have it, we ask csv.read, the name of the file. And here I use the pipe operator. I very much like the piping operators. I'm an R user, and I use a lot dplyr and the way this package uses the pipe operator. So piping is just whatever the output of this command will be given to the following statement. But it works only for a function with one argument. So here it's a way to define what we call an anonymous function. So it's like the math notation, where we define a variable and we tell Julia, okay, this is what you would do with this variable. So here is variable definition and the body of the function. Automatically it pipes the result as df and it puts it here. I like this notation. There are other packages that enable to write this more succinctly, but I like this notation because it gives you the opportunity to give a label, a name to a variable. So just by looking at this, I know that the previous line gave me a data frame, because I mean, once you get that df stand for data frame, then it's very easy to read, and visually I think it's very interesting. Just to clean up rm, just remove the file. So I download, so I always have fresh data. We can look at the data. Actually, if the semicolon here is something that inhibits the automatic display of the data that is the standard in Pluto and in the Julia REPL as well. So here, okay, I didn't. Yeah, there we go. So you see it's good practice always to look at the data and see what's happening. So we see here we have some missing, and this is very cool for data frame. This is actually what a data frame looks like. We have the columns here, and we see that we have 225 columns and 266 rows. So roughly 266 countries, and we'll see that it's not exactly that, but let's say that for now. And then 225 columns where the first ones have like the basic information about the area or the country, and then date by date actually the count of cases for the region or country. And we see here the word missing. Actually, this is the label for data not available, and it's well defined in language, and it's quite neat. So here we see missing because actually it's a country, and this column is for province. Actually, this is used for countries where we have the information per province. So Australia, we have the different provinces in Australia and the count there. So here it's the beginning, so a lot of zeros. Yeah, hope that it stayed like that, but you know. So one thing that we will need to do is actually have the total for countries that have many regions. We need to sum up for each day the total counts to get the count for the country, because it's not given here. So this is what we'll be doing next. Okay, so just up. we go there. Yeah, before doing that, we just some cleanup. Actually, just getting the dates as labels, because the dates actually were in the names of the columns. So this is names of the data, gives us the names of the columns, and then we select from 5 to the end. These are the ones that correspond to dates, and they are strings. So we need to parse the date. So as that Julia and the plotting package recognizes it as a date. So we define the format, which is a month, day, and year, and then we give that format to a function date. And we see here this funny dot here, and this is related to broadcasting. And this extends a function from working on a single element to working on an array. And this is really expressive, and I like it very much. So, and we see it here again, where actually the year here was encoded just with 2 letters. So it just, for example, for 2020, it was just 20. So actually the system just gives you 0020 as the year. So we add 2000 because this information is not expressed in the data, but we know that it's 2000. All right, the countries, same story here. We just check what are the countries that are available. We can check that out, and unique just gives you it removes repetitions, for example, for Australia and other countries where like that. So we see the bunch of countries. We need that for our menu, so that we can select which country we use. All right. Now to the selection of to the grouping and summing. For each country, we need to sum all available rows so that we have only one total per day. So how do we do that? So again, we have the data frame, which is data. Then we pipe it into a function called group by. Group by country. So it will split the data, the table, in multiple tables. In each table, it's only one country. Then we can do the operation on this. So if I sum all the rows, I get the total for this country. And this is what the combine function does. Combine df, and I give it the labels. Which columns do I want to sum? And these are the, remember here, the labels, it's the name columns from 5 to end. So these are the day labels. Then I just pipe it, like broadcast it with this operator to say, okay, for each column in these names, apply the sum, and it will sum the column, and it will change its name. But I want to keep the same name, so I give it another broadcasted assignment where I say, oh, use the previous labels as names. So this best thing to understand that is to try it for yourself, remove parts, and see what's happening. So there, when we do that, we see that here Australia is 1, and we have the total for Australia, and the same for all the countries that had multiple provinces. All right. Now we have our data per country in the format that we want for doing the plot. How do we do the plot now? And this is where we use the plot package. So the idea, just to give you a sketch of what's happening here, is that I'm making a first plot, which is a blank plot, and then with this function, add plot, I will add the plot for the country I selected. Because I want to select multiple countries, the idea is that I draw a blank canvas, then I write the first country, second country, third country, and so on. So I have helper functions, make a blank plot, add a plot for in the blank plot that I want to target, which country and which index. Index here just defines the range of dates that I want to use. So the function is quite simple. So a plot, I give it the plot, then a vector of dates, that will be the x-axis, and a vector of data, that will be the y-axis. But how do I get the country, the data for the specific country? And this is where I have a helper function, get country data. I give it the name of the country, and it will fetch it for me from the table And for the plot function, I need a vector, not a table or a part of a table. I've never tried to use like I don't know how much the plot package is interoperable with data frames. So just to be on the safe side, we just change it to a vector, and this is what this function does. So I start with the country, the data by country. I filter the rows to have only the one corresponding to the country I give, and this is filter. We say, okay, in the column country, use this function to know which rows to keep. And again here, anonymous function, variable value assigned to this body, which is I check if does the value equals the country, which is the input country. So if it's true, I keep it. If it's false, I throw it away, and I give it the data frame. So here you see that we nested like anonymous functions. The notation is so light that we can do that without losing the readability of the code. So here, the nice thing about that is that I know that for each country I have only one row. So I can use that and extract just the part of the data, removing the name of the country. So I select the first row, because this table only includes one row, and then all the columns from the second to the last. So I remove the first, which is the name of the country. And then here is still a data frame, and this is why I keep the name data frame here. And then I have this function convert, where I convert this data frame to a vector, and then I have my data. And you would tell me, well, there is no return statement and so on. Actually, the function returns the last statement, or expression that is defined. And here, actually, with the pipe operator, this actually sums up to one line. I split it on multiples because it's more readable like that, but it's equivalent to one line. This is an alternative way to do it without the filter. It can be maybe a little bit more readable. We just here I just target the US, and if I put it in a function, the country variable will go here, and we just say, okay, for a data frame, the left part is selecting the rows, the right part is selecting the columns. So I give it, for selecting the rows, select all the rows that for which this statement is true, which is I take df.country, which is take the column country, and check equals, is it equal to US? And I put the dot because this is a vector, and I want to have this evaluation done for each element of the column. So all the trues will be kept, all the false will be discarded. And here I select as we did here before to the end, and then I convert to a vector. So this is how these are like, I'm not making plots here, just functions that help me do that. So where do I do the plot? Actually, a neat thing about Pluto is that it enables you to hide the code. So this is a bit different than other notebooks. The code is below the output, not the other way around. So this is how we make the plot. We just make the canvas, make the first plot, empty plot with just the axes and the labels. And for each country in selected countries, we add the plot. So in our target plot, add the country and the date index, so that you plot just until the date I want and the country that I tell you, and you do one plot. Then, for example, this would go plot Brazil, then China, then India, then Italy, and so on, and then output the plot. So Pluto doesn't accept multi-line cells because of its reactive nature. So when you have multiple lines, we just wrap that into a begin and end block, so it's considered as one statement. So here, okay, we have a plot, but we don't see where the selected countries are coming from. Same story here. It's just that we are hidden the definition, and here we see the syntax for Pluto and how to link an HTML widget with the variable in the Julia environment. So this bind macro, I know that this macro because of the add sign, but we'll not dive into that more than that. So we define actually a selected country as the output of this multi-selection. So this is how we get the variables there, and then here not here we have the binder with the date index, where I have actually the number of the date. So I have the slider to select which dates at which date I will stop. So actually this is where I stop, and my conclusion is that it's quite neat. I like very much the ecosystem about data frames and plot. I think it's quite productive, and just to sum up, it's quite intuitive to use, especially if you know similar packages like dplyr in R, or I think pandas. I mean, if you really like pandas, there is a pandas.jl that you could use. But actually I have news for you about, as I said, the MIT course for this year is fully online, and the first video just launched, I think, yesterday, and there are some really good instructors. I mean, of course, you have like the David Sanders, Alan Edelman, who did the previous sessions, who are excellent. But this year's fall session, we have a grant from 3 Blue 1 Brown, which is an excellent educator in math culture and so on. If you like math, check his YouTube channel. I'll put the links in the description for the packages and these channels. And if you don't like math, check it out, because he might just change your mind. He's really good at explaining that. So check this course out. It's just starting, so you can start it right now and learn Julia and data-driven analysis and computational thinking using Julia and with great teachers. So that's it for this episode. So I hope it was enjoyable and useful for you. Please leave comments about what you would like to see next and so on. And see you in the next episode. Bye bye.